Good morning, everyone. I am D. Sangotayan, Assistant Professor of Physics, SNS, College of Technology, Coimbatore. Today our topic is laser. So laser, it means light amplification, stimulated emission of radiation. So the properties of laser: high directionality, high intensity, highly monochromatic, and highly coherent. So we all know that ordinary light spread everywhere. That means low directionality, low intensity, and polychromatic and less coherence. But laser light, it is a high directionality beam. So by using different types of mechanism, we are producing laser. There are different types of lasers are available. That means solid laser, liquid laser, gas laser, and semiconductor laser. So laser light producing important applications for industry as well as medical. Okay, we all know that ordinary light spread everywhere. That means low or very less directionality beam ordinary light. So that means spontaneous emission. If atoms moving from ground state to excited state, then back to normal. That means spontaneously work is producing that is called ordinary light. If energy is stimulated, that is called stimulated emission. By producing atom by atom, then the energy transfer from one molecule or one atom to another atom, that is chain reaction. For example, first atom triggering the second atom, then the second atom triggering the third atom. That means 1 to 2 energy transfer, then 2 to 3, 3 to 4. That means the reactions going with line by line, that means chain reaction. So finally the high intensity laser beam is emitted through the one side of the medium, that means producing laser light. So this diagram shows that the difference between ordinary light and laser. The second diagram shows that different wavelength. Then third one shows that equal wavelength. That means laser light. So the next diagram, the very simple absorption and emission of laser light and also ordinary light. The first diagram, the energy H mu, incident energy H mu is absorbed by the ground state atom. That means E1 state. Then E1 state atom moves from E1 to E2 state. So E1 it means ground state, then E2 it means excited state. So that is very simple. Initially all the atoms in the ground state. Once energy is absorbed from the light, then electrons moving from one level to another level. If the second state atoms, the lifetime is over, then back to normal state is called spontaneous emission. If second state atoms, E2 state atoms, are high energy atoms or excited state atoms moving from second level to lower level, that by using extra energy, that means that is called H mu. Then energy is triggering from one photon to another photon or one molecule to another molecule. Then energy is producing by chain reaction. There is these all are the difference between spontaneous and stimulated. The spontaneous, it means the work is done, the lifetime is over, then atoms are back to normal state by producing light, ordinary light. Then second source or third diagram shows that the energy is moving from E2 to E1, that by using the extra energy, that means H mu. So these are the difference between absorption and emission as well as spontaneous and stimulated emission. Okay, normal population and population inversion. So the diagram shows that all the atoms in the ground state, that means E1 state, then energy or atoms moves from excited state, the ground state excited, that means population inversion. So normal population, that means E1 greater than N2. Population inversion, it means E2 greater than N2. That means excited state atoms greater than ground state. Okay, there are different types of pumping methods are available by producing laser light. So we all know that very simple, laser is a high energetic light. So we required different types of pumping mechanism by producing different types of laser by using optical pumping, electrical pumping, direct conversion, inelastic collision between two atoms. These are the different types of methods by producing laser light. Then examples for types of lasers: solid state laser, ruby laser or NDOAG, neodymium tritium laser, liquid laser, gas, dye and semiconductor lasers. So these are the different types of laser system. So we are required different types of mechanism, different types of pumping method, different types of system by producing these different types of lasers. This is important for the producing lasers. next the Einstein's A and B coefficient for laser, that is difference between absorption, spontaneous emission and stimulated emission. Then the first equation shows that the absorption, so N absorption is equal to P12, that means atoms moving from ground state to excited state, so P12, then N1 equal to number of atoms in the ground, then Q equal to incident energy. Then spontaneous emission, the NSP spontaneous A21 N2, so A Einstein coefficient and 2 1, then atoms moving from second state to ground state, that is 2 1, the number of atoms in the excited state. So here there is no external energy, external force required for atoms moving from excited state to ground, that means spontaneous work. Then finally third one is stimulated emission, NST, so Einstein coefficient P21, the number of atoms in the excited state, then incident energy. So at equilibrium condition, the absorption is equal to spontaneous emission plus stimulated emission. If energy moving from spontaneously from excited state to ground state is called spontaneous. If energy is required moving from excited state to ground state, that is external force is required, that is called stimulated emission.